Alright, so let's go ahead and get started. So yesterday we started looking at the exponential functions and their graphs and kind of relationships between them. So we're going to dig deeper into those relationships today and kind of look at some of the values of some of those terms that we were looking at yesterday and what those values of those terms actually mean. So what we can actually do with them. So we're on 289. We need to fill out this chart here. Again, remember we're using the form of f of x given right here. So that's how you can refer to your a, b, c, and d values. The first two blanks, we're going to talk about the value of a. So the value of a. The first, for both of them, we're going to say if a is greater than 0, and for the next one, if a is less than 0. So those are how both of those are going to start. But what we need to do, we need to go look at all those graphs on the previous page, look at all the functions, find the value a of all of them, and see what's in common. Look at the a, look at the graph, and go to a next one. Look at the value of a and look at the graphs. So take some time. If you want to talk it over with your partner, that's okay. Take a minute. Look at all your graphs on page 288. Look at the values of a and see what you notice about those graphs. And again, while you're doing this, make sure you pay attention to this function f of x. A is not the value that has the exponent on it. So be careful when you're looking at the formula. Does anybody have any guesses yet? Still looking? Rebecca?
Well, if A is positive, then the graph is above the horizontal asymptote, and if it's negative, it's below.
Exactly. If we look at these, if the value of a is greater than 0, it's above the horizontal asymptote. So if we look at the first two, it's positive out in front. This would be a value would be 1. The a value here would be 1. It's above the horizontal asymptote. But if we look at problem 8, we have that negative 1 out in front, and it's below the horizontal asymptote. So we are going to say if a is greater than 0, the graph is above the horizontal asymptote. Then the converse of that, for if a is less than 0, go ahead and write the graph is below the horizontal asymptote. So now we know how that value of a affects these functions. We're able to determine if we see we have a negative value, we know it's going to be underneath wherever our horizontal asymptote is. If it's positive, it's going to be above it. So now we know something about it. Now we need to look at the value of d. So it says we're going to have three different statements about the value of d. So look at your function, look where the value of d is in a standard function up above. You can go ahead and look at your graphs at the values of d. And what do you think the three statements are going to start? They're going to be something similar to what we had for a, but we have three statements. Take a minute to look at those, see if you can figure out what the value of d does. Alright, has anybody found a pattern? Notice anything about the value of d, what it shows you on your graph?
the
ahead.
horizontal asymptote?
Okay, it's telling us where the horizontal asymptote is. So for the first one, if D is greater than 0, what's going to be true about that if D is greater than 0? You told me it tells me about the horizontal asymptote, but what does that tell me if it's greater than 0? Marie?
The horizontal asymptote will be above the x-axis.
Exactly. The horizontal asymptote is above the x-axis. What if D is equal to 0? What do you think would happen? Marie?
The horizontal asymptote is on the x-axis.
Yep. The horizontal asymptote is on the x-axis. And lastly, if D is less than 0, the horizontal asymptote has to be below the x-axis. So now we're able to determine a few things about our function by looking at an a value and a d value. You can figure out some characteristics of your graph. Do you have any questions about filling out this chart at all? I'll leave that up there for another moment. When you're done, we'll go ahead and turn over. Alright, as we look at the back page, 290, it says using the exponential functions on page, that should be page 288, if it's not written in your notes. Page 288, complete the following table. At the beginning of the next lesson, we will make inferences about how to determine from the equation if a function is a growth or decay simply by looking at the graph. So what we're going to do, these are numbered according to the graphs on page 288. So we're going to do a few of them together, and then I'd like you to try some on your own, and then we'll check some answers. So let's go ahead and look at number 1. So you're going to need to look at number 1 on this page and refer to number 1 here. So does the graph of the function increase or decrease from left to right? Look at number 1. Increase. Does it increase or decrease from left to right? Marie? It increases. Classify the graph as a growth or decay.
Growth.
It's a growth. Based on the equation, has there been either an x or a y reflection or none? Remember, we went over that yesterday, what to look for. Now it says they want you to look at the graph. So they don't necessarily want you to look at this, so let's talk about what's happening here. An exponential function has the form of going like, let's just draw it here, something that goes like that. Okay, what's that horizontal asymptote? So is it reflected on the y or the x at all, or does it look like a standard form? This one doesn't look like it's been reflected at all, so this one is none. We're going to go over some that have been reflected. So, okay, let's look at the last column. They're talking about the value of b. Is b greater than 1 or is b between 0 and 1? And look at the function form here. So they tell you where b is at again, if you've forgotten. Is b going to be greater than 1? Or in between 1 and 0? Go ahead. Yeah, b is greater than 1. All right, let's go ahead and look at problem 7. So 7, does it increase or decrease? It decreases. And we may use the function to help us out a little bit in this one, but let's look at the growth or decay. Do you think is it growth or decay? Go ahead. Decay. So again, you can use the statements that we wrote yesterday. You can refer to those to help you. And now let's see, based on the equation, has there been either an x or a y reflection? So go ahead and look at the equation on number 7. Based on the equation, has there been either an x or a y reflection? Again, we went over those yesterday. If you need to look back, take a minute to look back. We talked about those reflections, which caused each. So based on the equation, what type of reflection do we have? Ashlyn? A y-axis reflection. Okay. And for number 7, is the b value greater than 1 or between 0 and 1? What is the b value? Anybody have the b value? Ashley? It is greater than 1. b is greater than 1. Let's do number 8 next. Go to number 8, please. So number 8, increase or decrease? Just yell it out if you know it. Increase. Decay or growth? Decay. Now, reflection. Y, X, or none? X-axis. And value of B. Between 0 and 1 or greater than 1? Between 0 and 1, yeah. All right, so that's how the setup of this table is going to go. Again, you need to look at all 12 of them, so I'm going to give you a few minutes. Go ahead and complete the rest of this table. If you want to work with a partner, that's okay too. And then we'll go over some of the answers, but I think you're grasping the idea pretty quickly. If you have any questions, call me over. I can look at your paper. Yeah, so if we look at our definitions that we wrote, you're looking from the left to the right. So this one here is what you're looking at. So start on the left and go to the right. It says if it goes from left to right, it moves away from the asymptote, or it moves towards it. So what happens when you go left to right? It goes towards the asymptote. So
Can you also look at that exponent for decay too?
so what do you mean by that?
Because say before I want a decay because I said it's equal to 0. Because I remember yesterday you mentioned that the exponent for decay was 7. So like the exponent, like this one we did yesterday, they use negative x, I use decay instead.
So the way you can think about that, you can think about it this way. So this is 2 to the negative x. So really, that's 1/2 to the x power. So then, that's a value that's less than 1 if you think about it that way. So yes, it would be a decay.
Okay.
So that's why we were thinking about the power.
Okay. Thank you.
So let's see another one. So this one here. This is a value that's less than 1. But it's not a decay because that's a negative x. So you would take this value less than 1, flip it over. If that was technically a fraction, then it's going to be greater than 1, and it makes sense because it's a greater than.
Okay.
So that's how you can use that.
Okay. Thank you.
Yep. Yep, exactly. So the value b, this is whatever is being raised to the exponent. So for example, the value b is 2/3, that's what has to be exponent. So 2/3, is it greater than 1? No, it's in between 0. Again, yes, that third column, strictly based it off looking at the equation. They want to know whether it's x, y, or none. See a good mix. Half of you are done, and half are finishing up. So in a minute or two, we'll start going over the answers. Alright, most people are finished up, so we'll go ahead and start going over these. If you want to, you can just say some answers out loud as we write them down. So number 2, if you know it, just say decrease or increase. Decrease, thank you. Growth or decay? Decay, thank you. X, Y, or none? Again, for that one, looking at the equation, make sure you're looking at the negative sign on either the a value or the exponent. That's how you determine that. And B, in between 0 and 1 or greater than 1? In between. 3. Decrease or increase? Decrease, decay, or growth? Decay. X, Y, or none? Greater than 0 or in between, or greater than 1 or in between 0 and 1? I think I heard both out there. Let's look at it. 3. Look at 3. Yeah, it's going to be in between. It's okay. 4, increase or decrease? Increase, growth or decay? Yep, you guys are getting better at this. X, Y, or none? Greater than 1 or in between 0 and 1? Alright, then 5 is going to be decrease, decay, none, and in between. Let's check your answers. 6, increase, growth, none. These greater than 1. You guys agree so far? Okay. We did 7 and 8. Let's go to 9. I have increase, growth, I have y-axis this time, and in between 0 and 1. Good so far? 10, I have decrease, growth, x-axis. And again, one more time, since we had both of those, I want to go to 9 and 10 just to clarify that. So on 9, we see the x has a negative. That's why we know it has the y-axis. And then for 10, the x-axis, the negative is on the a value. So we know it's reflected over the x-axis. Let's look at it. So 10. So as you go from left to right, you're starting on the left, go to the right. Does it go towards or away from the asymptote? It goes away from the asymptote, so that one has a growth. Even though it's underneath the asymptote, it goes away from the asymptote. Does that make sense? Okay. 11, increase, growth, y-axis, and I guess I forgot that on 10. So 10, b is greater than 1. 11, in between 0 and 1. 12, decrease, growth, x-axis, and greater than 1. So make sure all your answers match up. Do you have a question? Yeah, Marie, go ahead.
12 is growth.
Let's look at 12. So we see that it's decreasing. And let's look from left to right. So as we go from left to right, we wrote a definition down yesterday. Do you have the definitions at the bottom of this page? It's not on this one because I erased it from yesterday. So it says from left to right, let's look at a growth. It says it moves away from the asymptote. So from left to right, does this one move away or go towards?
Moves away.
Moves away.
Just 'cause those flips up.
Yep. That's the same as number 10. 10 and 12 are kind of the same. They're both flipped upside down. That's that reflection of the x-axis, that negative in front. Again, if you look at 10 and 12, if they didn't have that negative out in front, do you see how they would be on the upside and it looks like that normal growth? That negative out in front is what flips that down. Again, that's what makes that reflection. Okay? Any other questions? That was a good one. All right, so that's where we're going to stop for today with about a third of the class out. I don't want to go any further. And Mrs. Bauer is going to pick up with us on Monday. Yes. So that will be picked up on Monday on the next section. The rest of the class, you have a little bit of time left if you want to use that for homework. Get ahead and get caught up on the homework. That way you're ready to start on Monday. Okay?